Welcome to our first lesson in our rates and proportions unit. This one is on rates and unit rates. And our essential question is, why are unit rates useful for comparing different quantities?
Okay, here we go. A rate is a ratio or a fraction comparing two quantities with different units. So we're talking about real world problems, real labels.
And that's the key, is those units there for you.
Samantha picked 45 oranges in 5 minutes. Write this as a rate. So we're going to write 45 oranges on our numerator and 5 minutes on our denominator. That is a rate.
And that's as simple as it is. The general rule of thumb is it usually goes in the order that they gave you the information, unless the problem asks differently. Next one is a unit rate, and that's what this lesson's really about. It's a rate that has a denominator of 1. So it's a special kind of rate. It's how much it is for just one of something. To write a rate as a unit rate, just divide the numerator and denominator by the denominator. And I know that kind of sounds complicated, but you kind of see what it means. But it really just means you're always going to divide by your denominator. So you never have to think about what to divide by.
So if we go back to the example we just did, 45 oranges in 5 minutes, we're going to actually do the division of this rate to make it a unit rate. So 45 divided by 5 is going to give us 9 oranges per 1 minute.
And the denominator is always 1 because 5 divided by 5 always gives us 1. And that's what our goal is, to have that denominator of 1.
All right, so write these rates as a unit rate. So each of these problems will have 2 parts to it, the rate and then the unit rate. So he's starting us out with 125 feet in 5 seconds. So 125 divided by 5 is going to give us, thank you, 25 feet
over
1 second.
Okay, but you got to write it as a rate with the units, show us what you divided by, and then your answer has to include the units. So 12 meters in 28 seconds. Again, it's not a fraction, you're not simplifying, you're always dividing by that denominator. So it's perfectly normal to get decimals in this case.
Which you're about to get. So
12 divided by 28 is?
43. I had to round that to the nearest hundredth, by the way. What are we doing? 43 meters about in 1 second.
Okay, so we got a big long decimal, but Mrs. King rounded that off to 2 decimal places. So we got 0.43 meters, so not quite half a meter per second.
We have 360 miles on 12 gallons of gasoline. So how much per 1 gallon of gasoline?
Oh, sorry.
GAL. So 360
gallons
divided by 12 is going to give us 30. We are striking out in this writing. 30 miles per 1 gallon.
See, we're seeing if they're paying attention. They should already know what to write before it appears on the screen, because you've already said it.
I needed this in green, by the way. 4 potted plants for $88. He's going to tell us.
Money is always going to go on top. So even if it's listed second, it's easier to break money up into pieces. You can think of parts of $1. Over 4 plants
is how much for 1 plant?
So I'm going to get $22 for 1 plant.
Sounds expensive.
So our unit rates are always telling us how much it is for just one of something. For 1 second, for 1 plant, for 1 gallon. How much is it for just one of them?
Pretty easy so far. Julia read 52 pages in 2 hours. What is the average number of pages she read per hour? So we're starting with our rate, 52 pages in 2 hours.
And we know to set it up that way because of how it said. Pages per hour. It's telling you how to set it up.
And then we're going to our unit rate. So 52 divided by 2 is going to give me 26 pages per 1 hour. And then we go back, make sure our answer makes sense. Yep, it's an average number of pages she read per hour.
All right. Next one says find the unit price. So unit price is the price for 1. How much is it for just one of something? It costs $2 for 8 juice boxes. So money goes on top. Over 8 boxes.
And it's going to seem weird since $2 is less than 8. We're still going to get less than $1. So $2 divided by 8 is going to give us 25 cents a juice box?
Yep. For 1 juice box. So you're always dividing by that denominator.
At the store, they divide for you, and they put it in the bottom of a little scanny thingy.
Usually it's yellow at Walmart in the corner of the unit price. All right, Tito wants to buy some peanut butter to donate to the local food pantry. He wants to buy as much peanut butter as possible, so he needs the best deal. Which brand should he buy? So we're comparing different prices and different sized containers.
So you get your calculator ready because we got a bunch of decimal work to do. $2.19 divided by 12 ounces.
So we wrote it as a rate. We always divide by that denominator. That's why she's dividing by 12.
Can you write all this down? 0 and 100, 1825. We need to discuss how to round. So when we're talking about money, we need to discuss dollars and cents. So we round to the nearest penny, which is the hundredths. So we need to look at underline the 8, look next door at the 2, decide if that 8 stays 18 cents or if it rounds up to 19 cents. In this case, 2 is less than 5, so we're going to do 18 cents over 1 ounce.
So don't just ignore the digits after the second one. You have to use your rounding rules and round it appropriately. So that was for the Nutty brand. Now we're going to do the Grandma brand. So you're doing this for each one. It is $2.79 for 18 ounces. So it's a different price, but it's also a different size, and that's hard to compare.
We're going to go 16 cents an ounce. That actually worked out as 0.155, and I needed to round up to 16 cents an ounce.
Okay, then we have the Bees brand. Sounds more like honey than peanut butter, but that's all right.
Maybe that's the grandma's name.
So $4.69 over 28 ounces. Money always goes on top. We always divide by the denominator.
So we're going to have to round up again, 17 cents an ounce.
All right, and then our last one
sounds like a store brand.
Save-A-Lot. You're going for store brand here. So $6.60 over 40 ounces.
That rounds up to 17 cents an ounce as well. So we then
I promise it's going to show up eventually up here.
Then we have to look at our unit prices. We have 18 cents, 16 cents, 17 cents, and 17 cents. So he wants to buy as much peanut butter, so he needs the least price per ounce, which is going to be Grandma.
Okay, and you might be looking at it, goes, oh, 1 cent, that's no big deal. Well, that's 1 cent for every ounce. So in an 18-ounce jar, that just saved you 18 cents. In a 40-ounce jar, that just saved you 40 cents over that other one, because it said he can buy as much as he wants. So if Grandma's is the best deal, yeah, it's a smaller amount, but he could just buy more of those jars because it's a better use of his money.
See you tomorrow.